All right, so this is the third special topic on the data analysis for the COVID-19 pandemic. And in the previous one, we've done different things. And today we're going to look at geospatial data analysis for this epidemic and using the module called GeoPandas. So in the last lecture, we learned basic mathematical modeling of epidemics and how the dynamic evolutions based on different populations, including the exponential model, which doesn't work for long time evolutions, the SI model, SIS model, SIR model, which one's immune, one's no immunity. And also we learned talk about SEIR model with exposed population, and that's one of the homework assignments. So the details or the mathematical properties about these models are less important in this for this course. And the idea is that what you learn and how do you use Python to implement models like that in the future when you are doing other things, not just epidemics. So in this lecture, you will learn one more technique called geospatial data analysis, and also sometimes it's referred to GIS, but GIS is a subset of geospatial data analysis. And to do that, and we will be using the GeoPandas module and how to work with the geo data frames, and also visualization of geospatial data using Python. So after this lecture, you'll be able to generate maps with colors of the cases, etc. All right, so what is geospatial data? So geospatial data comes in many forms and formats, and it's actually very complicated than just simple geometry data, right? So the key behind all geospatial data that's defined in a coordinate system, right? So what makes geospatial data so different from other data sets is that it has to be referenced. And for us, we're living on Earth, so we have to be referenced on the planet and or a geo-referenced into a coordinate system, and it's a terrestrial system, right? So the point here is that the geospatial data, especially the geometry information, has to be identified or agreed between different software, different platform, and even in different languages and things, right? So for example, like why math is commonly used, because we all know what's the value of pi, which is defined internationally, or the natural number, or the function of logarithm, right? Because everyone see that function of logarithm, we know what that's working. So that's the same idea as geospatial data, is that we define the coordinate system of the geometry, and it's recognized by everybody. So everybody's agreed on that, right? So that makes the geospatial data very special. So in Python, geospatial data is basically a data frame, or pandas data frame, plus geometry. Right? So we go through the details, ideas about geometry later, but I will show you a couple of examples. The first example, you've probably already seen this if you've been looking at the Johns Hopkins University coronavirus map. And this is one first type of map you see. It's like a Mercator projection plus all those bubble plots showing you the size and the location of the virus outbreak, right? And you can do this by using pandas plus basemap, and that's also type of geospatial data. And remember that you've done maps to calculate the trajectory or visualize the trajectory of typhoons, and also working on the the starting point, ending point of the typhoons in a map or with different projections, and that's also one type of geospatial data analysis. So you've done 50% of work. Right. So the second part is this map, which is also a word map, which is a projection, looks like a hammer projection, but it's colored by number of cases confirmed, in this case, up to a week ago, right? So this map cannot be directly generated by basemap plus pandas, so we need to use GeoPandas, and that's what you're going to learn today. So after today's lecture, you'll be able to generate both type of maps based on the data and shapes given. All right, so Why do we using Python for geospatial data analysis? Of course, lots of people using commercial softwares for GIS. So GIS here is a geographic information system. So it's a part of geospatial data analysis. And people use other things like ArcGIS, QGIS, or PostGIS, etc. And we here, as an introduction, I decide to use Python as a quick introduction to show you what you can do with Python. And because, first of all, it's free, it's open source, right? And you don't need to buy expensive license for things like ArcGIS, which is very expensive. And you learn and understand much more deeply on how do you do with the data processing, which is a much lower level language processing of coding than those commercial softwares. Right? So usually you don't have, you've been working with Python for a while and you have noticed that when you want to do something like generating a map, there's no user interface for you to select and click and generate things. Everything has to be started from simple codes, right? So it's a much lower level programming process, and you can have a better understanding of what's really going on in those codes, right? And Python is also very efficient and flexible, so it can be used in other places like big data and other platforms for supercomputing, etc. And also it supports the open source software. I'm a big fan of open source policy for science, especially research. And so that's why I would recommend you use Python, which is free of charge anyway. And last thing is that for more advanced users, and Python is really good at gluing things together, like plug in and using a third-party softwares when they're available. So that's really good to use. All right, so let's take a look at example of generating a bubble plot using pandas and basemap first, which is the first type of geospatial data. All right, so remember that if you've already worked with the total and daily cases COVID-19 CSV file, and we load the file using the pandas pd.read CSV, and I changed the long tedious name to be total cases and daily cases. And because it has multiple dates, so I'm only selecting April 1st, which is last week, because I'm too lazy to update my database, and you should do that on your own. All right, so this is the data frame that we get, and you can see that I get entity code, date, total cases, daily cases, etc. Right, so now, if we want to map the number of cases to a map, first thing you need to do is create a map using basemap, right? So that's a review on what we did. So we load the basemap, import basemap, and we create a map projection, which is M. So M is a map using basemap, and projections indicator. I'm setting up the latitude, longitude, bounds, and draw coastlines, draw parallel, and meridian grids, and fill the continents, change the color, and make the map. So this is the map you get, right? So that's something we've done in the previous lectures, generating maps. So now the question is that, what I'm gonna do, because I want to show bubble plots on the map showing where those cases are geographically. So I need to map this point. For example, for Afghanistan, I need to map this 166 as a bubble to this map. So what do I need? So the first thing you would think is I need a longitude, a latitude, of where to put that bubble, right? So I cannot do with a single data frame, because there's, in this data frame is the COVID-19 data frame. There's no geometry information in this way, right? So I need to get the geometry information from another data frame. So here comes new one. And then we're gonna learn a trick how to merge data frames based on common columns. Right, so let's take a look at this data frame file called geo.csv file. So this is a file, gives you the name of the countries and the capital or central location of those countries and where the geographic latitude and longitude are. Right, so if we just simply do, the file name is geo.csv, and pandas, which is PD, read csv.fn, and then let's take a look at the head. And we got this data frame, but it looks pretty bizarre, right? And it doesn't look like anything like a data frame we worked on. So if you look carefully here, you can see that at each country region, and there's /t, and latitude /t, longitude /t, and name. So you kind of realize that there's a separator in this CSV file, or the delimiter in the CSV file, but pandas have not been able to identify that correctly. Right? So the point to fix that is that when we load the file and we set sep equals to /t, which is tab, right? So by doing that, now we can get a much proper data frame, and you can see the columns, which is country region with 2 letter codes of the country names, latitude, longitude, where that country is, and we use that to map, and also the name of the country, right, in this way, right? So recall that the COVID-19 data frame, DF_C, which is the data frame on April 1st. And you can see that we have entity, which is the name of the country, and the code, which is the ISO 3-digit codes for the country names, date, total cases, and daily cases, right? So the idea here is that you notice that we have common informations between these two data frames, which is the country name, right? One is called name, the other is called entity, right? So the idea we want to do is that, is there a function that we can merge these two data frames together into one data frame? So now we can use the latitude, longitude information to map those total cases, right? So now merge comes into the picture, right? So the first thing to do is that we need to make the column names the same, because that's why, because Python pandas merges data frame based on the column names. If the names are not the same, and you cannot do the merge. Right? So the first thing we do here is we rename the geo data frame, which is this one. So if you remember, the rename command is we set columns, we change name to the entity, and in place equals to true means that I want that immediately. So after we did that, and this column is changed to the entity. Now that's exactly the same as the COVID-19 data frame, right? So now the next one is the merge, right? So the syntax goes dfc.merge. So I do this, I want merge this geographic data frame into the COVID-19 data frame. So I call the merge function, or the dfc, which is the COVID data frame. So I merge geo into dfc based on entity and how it goes to inner, and that's just based on how we which is a nicer option, and you don't actually need that, but I usually put that in. So now when it's merged, I give it to a new data frame called demerge, right? So the data frame, and that's the other data frame, merged on entity here, right? So if I do demerge.head, which is the merged data frame, and this is what I get. And let's take a look at it. So compared to the COVID-19 data frame, I'm getting the country name, entity, codes, date, total cases, daily cases, which is basically this one. Now I'm also getting country region and also latitude and longitude, right? So now I've got everything in the data frame to do the mapping, because I have the longitude, the latitude for a map, and also the number of cases for a map, which is size of the bubble, right? So come back to that, which is relatively straightforward. So it's going to relate it to the element access of pandas data frames. So the first thing I would do is that, because I like to give an index to the data frames based on which is the country name. So I changed the country and region index column to the entity, right? And then I use the set index function to make that column to be the index. And then I look at the demerge data frame, and you can see that now my index became country and region, right? Based on this, I can access the longitude and latitude of any country easily using the element axis. For example, if I want get longitude and latitude of Afghanistan, so what I do here is I got lat, which is basically this one, this value. So lat equals to demerge the latitude column, and which index? Index is use the lock function and C is Afghanistan. So Python knows that, pandas knows that I want this latitude. And the same thing applies to the longitude, right? If I print out and I get these two numbers very nicely, right? So based on that latitude and longitude, and then we can make a bubble on the base map, which comes this way, right? So let's take a look at this code. So this is the code using the base map to generate a world map using the Mercator projection and without colors, just the country lines, right? So that's all the filling, and you're probably already familiar with this. I'm not going to go into details. And now let's just map the total cases of China in the world map using a bubble plot. Right, so I need three information. One is the latitude and longitude, and this is the way how I access the information from the merged data frame. And then before you go, you map the position, and remember that you always need to map the longitude, the latitude, which are in geographic coordinates, into the map coordinates using the M function here. So now X and Y, they're corresponding to the latitude and longitude in the map coordinates, so I can make plots to be visible, right? So I need another parameter, which is called case, and that's number of cases. And how I'm going to use it, I'm going to use x, y as my location points, and case divided by 20, that's the size of the bubble. And bubbles has color red, and I make it transparent, 70% transparent. So if I show this, and that's the plot I get, right? So the case divided by 20, that's something I did it by eyeballing the size of the bubble to make sure I like it. Right? If you don't do that, you get a giant bubble here. So you need to kind of scale it down. Right? So it's up to you. So what happened here and need to do is that first you create a world map with the Mercator projection, and then we find the latitude and longitude of a country, China, and we map the longitude and latitude to a map coordinate system, and then we use the scatter plot to plot the bubble on top of the map, and then we get this location with the size of the cases, right? All right, so now we can map a bunch of locations. We can map every country's cases into the Mercator projection by simply doing a column, right? So now I'm getting access to demerge latitude column. So that's the latitude of all the countries in the demerged data frame, and also the longitude of all the countries in the data frame. And remember that np.array, that's the NumPy function to convert these columns to be a NumPy array. And if you don't do that, and the base map might be complaining that this is not it's not a one-dimensional array, because the series or the pandas columns usually have another dimension, which is the index. So if you do converting the longitude and latitude column into NumPy arrays, and you will not have that problem. So for the cases, I'm also converting all the cases column into a NumPy array. So I can plot the X and Y locations of cases. Now X, Y, and cases, they're all one-dimensional NumPy arrays containing all the longitude and latitude and total cases from all the countries, right? So if I run it, and this is a bubble plot again, right? So you can get, lots of cases. You got a big bubble in China, and all these overlapped bubbles in Europe because there are lots of cases going on, and a giant one in the United States because that's spreading, and you can clearly see that the virus outbreak is mostly spreading in the northern hemisphere, and there are much less cases in the southern hemisphere up to March 30th, April 1st. So that's how we generate a plot like this, and this plot is actually pretty close to the one that you see in the Johns Hopkins University website. And by doing this, and you kind of learned the detailed processes of how to generate a plot like this. This is basically quite similar to the typhoon hurricane trajectory plots, and it's just using this for the coronavirus data set. And pay attention to this label, a legend or whatever. So this is actually done by manually using a for loop and setting up the locations and sizes of the bubbles, and also the annotation based using the text function. So if you're interested in generating something like this manually, and you can take a look at that code. I'm not going to go into the details because everything is very basic. All right. So the next part of this lecture, we're going to take a look at how to map those cases into the world map, say using the Mercator projection with colors. Right. So what we're going to do is we're going to introduce a new module, a library called GeoPandas. So the GeoPandas has the official website, geopandas.org. So if you go to the geopandas.org, you'll be able to find the documentation here very nicely. So take a look at the details here if you're interested in more details on the geospatial data analysis. And to install GeoPandas, because GeoPandas is not a default module in Anaconda. So if you remember that what you did to install the base map module, and what you do here is go to the environment and go to the not installed one and search GeoPandas here. And then when you find it, click select and click apply and wait for several minutes and you're done, right? So that's how you install GeoPandas, and you should try that for the homework problems. Right? So the GeoPandas data frame, it's fairly complicated, but in short, GeoPandas is a nice marriage between the geometric shape, objects, and the data frames. So it's basically data frame plus geometry or geographic informations, right? So GeoPandas is open source, and it's open source to make working with geospatial data in Python. And there are all kinds of data types in GeoPandas, and they performed by different libraries like Shapley, Fiona, Descartes, and others. I'm not going to go into the details. And the idea here is not trying to learn everything, but for as a beginner introduction class, we just learn there's GeoPandas, and this is what you can do with it. And if you want more details, and you should go to documentation and learn it yourself. And that's actually the right way to learn things like Python, which is open sourced project anyway in the future, right? So let's take a look at GeoPandas. And as an introductory course, the requirements is that you're going to be able to use GeoPandas to generate a world map or a part of the world map and color it with whatever information you want and do analysis, right? So import GeoPandas as GPD, so GeoPandas. And if you create, so we need data files, so like read CSV, read Excel. So the load command to load a data frame or geodata frame from GeoPandas is called read file, right? So read file, you give a file name here. But for this one, we're using a built-in file from the gpd.datasets. So in GPD, in the GPD module, there's a folder or there's an attribute called datasets, and there's data file called natural earth low res. So that's the earth information of the earth countries with the low resolution geometry, right? So once this is created, we have a new data frame called world. So if we look at world.head, and this is basically the data frame we get, and you can see that we have information, so that's different columns of different information like population, which population estimated, continent, name of the countries, and that's the ISO A3 digits of country codes, and GDP, in US dollars, and also geometry. So what's different here is that world that's the same. It's a geo data frame, called GeoPandas data frame, and it has a column called geometry that's not familiar compared to the default pandas data frame. So the geometry data frame is an additional column added to a normal data frame with geometric objects, shapes. And you can see there's definition of multi-polygon, polygon, and multi-polygon. And these are like just basically locations describe what the shape looks like, right? So we're not going to go into the details. So the ideas want to tell you that in the shape, a geometric objects are the shape. And there are different types of geometric objects. For example, you have points or multiple points, right? So for example, points, that's the geometric location for the capital cities, right? So that will be the geometric object for cities. And also lines. So lines, it could be a geometric object for a trail, right? If you're we're in a ski resort and you need to map the trails of the ski resort, and you need the line objects. And also polygon, and polygon objects that gives you the shape of a country or the shape of district, something like this, right? So not going to the details and just give you a sense of these are the geometric objects. They have different types, and when you see them, just don't panic and just say that's the information we can use, right? So here's the fun part, right? So now world is the geodata frame that has population, GDP, and also geometry, and country names and geometry, right? So based on the geometry or the shapes, and if we just do world.plot and set a fixed size, and you can see we get a world map with the Mercator projection, or almost Mercator projection directly, and colored by a blue color, which is a default, right? So that's, you know that the plot function gives you the world map, right? Okay, so since it's a pandas data frame, so geodata frame is a pandas data frame plus geometry. So all the data wrangling or the operations filtering that we learned for a pandas data frame, you can use that for the geodata frame easily, right? So what we do here, for example, if we want to only select the countries with population greater than 0, of course, what does that mean if a country has 0 population? And also, we don't want Antarctica. So world name does not equal to Antarctica. So by doing that, I'm selecting the new geodata frame based on these two conditions. And also, I'm creating a new column by using NumPy type of operations, is dividing the GDP estimation by the population estimation times 10 to the 6. Right? So this is basically GDP that's basically GDP per capita, and I'm saving it to a new column called GDP per capita. And then once we did this, and you can see that I have a new data frame, and then there's a new column called GDP per cap, and that's calculated based on these two columns, right? So that's the same as the pandas operations. And also we can select a continent. For example, if I want to only show map, or I only want map information for Asia, and what I can do is I can create a new geodata frame called Asia, and that's done by filtering the continent using Asia, right? So that's world continent double equal to Asia, and then I save that to be Asia. And now if I do Asia plot, and I get a map of all the Asian countries in the Mercator projection, right? So a couple of notes here. So the geo data frame are based on pandas, and you can use all the data wrangling methods we learned before in pandas by creating new columns, removing columns, change index, filtering based on conditions, and also use the additional data column called geometry to map the data into your map. So that's the key difference between the geo data frame and a pandas data frame, right? So how are we going to do that? So the first thing we're going to look at is we're going to use map data to create a choropleth map, which is colored by a color bar, right? So remember that if we just did the world.plot and you get a plain world map colored by blue, right, which is not particularly useful, right? We know what the Earth, the continents look like. So now, if we want plot the world map and color it by the GDP per capita, so here's what the syntax you do. So world.plot figure size, so it's a key column equals to GDP per capita. So what I'm telling GeoPandas here is that I want a plot of the world map and based on the geometry in world. And I want color it using the column called the GDP per capita. And CMap is a color map. I want orange to red. So very low is orange, very high is red. And scheme is quantiles. So you can change this later. I'll show you how to do that and put in legend. And this is set location where the legend is, and these are labels and titling and show it, right? So if I run this code, and this is a map I get, which has a lot more information in it, right? So you can see that now the colors, different colors are showing different GDP per capita of countries over the world. And you can see that it's a lot higher in North America and lower in Asia, Africa, in lots of countries. And you can see that Python also automatically creates a legend showing you the range of different colors corresponds to. Right, so in this case, and here if you want more colors, and that's one of the part of the homework, and you can try to choose your favorite colors by looking at this page of what kind of color maps you can choose. Right, so the key here is use the same function plot, but now specify a column with the data that's colored by a color bar specified by the color name. So you need the name of the column and the color bar in this case. Right, so you can also do things like aggregations, like group countries together based on continents. So there are lots of other things you can do, and this is probably the simplest that people use. So for example, if I want plot the population based on continents, so what I do here is that I load the data frame and I filter the data frame by population greater than 0 and the country name doesn't equal to Antarctica. And what you do here is that we use the dissolve function. So it's world.dissolve. So how I'm going to dissolve my data? I want to dissolve it by continent, right? So now it's GeoPandas is doing something by creating everything, grouping everything has the same continent together. And the aggregation aggregation method is sum. So basically grouping the countries by their continent and add them together, right? And then I create the new data frame called continents, right? So in this case, I want to divide by continents by billion. So the population divided by billion, and I look at it now, I have a new data frame which only has 5 rows of data: Africa, Asia, Europe, North America, Oceania. Oh, well, there's South America as well. So you can see that I have geometry, which is there, and population estimation. So that's basically the sum of all the countries in Africa, all the countries in Asia, and all the countries in Europe, etc. Right? So by doing that, and I can plot the continents, use dot plots, and I specify the size of the figure and edge color, which is the color of the country lines, and we use a very thin line, which is 0.2, and I'm gonna color it with the pop est, which is basically this one. And column, that's the key. That's where how the data is going to be colored. And scheme is quantiles. And I'm using a different map here and putting in legends. So if I run it, this is a map I got, right? So now you can see that different continents are colored by different color because their population is different, right? So this is in billion, and you can see that, oh, well, this is billion, yeah. And you can see that this is Europe, so Asia and Africa has the highest population compared to the rest of the world, and it can kind of see, where's most of the populations, are populated over this on this planet, right? So this is how you group data together based on their continents, and you should try this. There's one homework problem asks you to try this to do that with the COVID-19 cases. So this is the basic technique you're supposed to use. Right. So here's another topic which is a bit advanced and which is not required. So I'm not going to go through the details about this. And so the thing is that those ones that you can, if you want a more resolution on the color changes in your map, and you should use a color bar instead of using a quantile, right, in this way. So I'm not going to go to the details, but if you're interested in and you either need more libraries like this, and there's a code in the Jupyter notebook, and you can play with this using these code, basically using copy paste these codes and generate color bars. So what it does is that instead of creating step-like colors for coloring the GDP per capita, it's on a more continuous color bar in this way. So you can have a more data resolution to show the changes of the GDP per capita based on that column, right? So, and that's an optional topic you can look at. So the other one is mapping things on different layers. For example, there's another data file, data frame in the GPD called cities. So if you look at that and you get name of the cities and location of the city, which is geometry here is a point, right? Because that's a city. So I just need the longitude, latitude of that city. So if you do this and you can actually map generate a map based on the GDP per capita, and then you map the city locations based on the other data frame. And if you do that, and you can generate something like a choropleth map based on the GDP per capita, and also map the locations of the major cities of this planet, right? So that's something very similar to the base map stuff that we did. Like when you generate, it's the basic same as the bubble plots. We just have different layers, right? You do one layer and then plot the second layer using the axis name. But this is not particularly new and interesting, but that's a technique that you should know. If you need to do something like this, go to this page and take a look at it. All right, so now let's take a look at the most important part of this lecture is how we map the situation of COVID-19 cases in world map in this way, right? So recall that we have the data frame of the total and daily cases COVID-19.csv, and with changed column names in this way. And we are only selecting one day on April 1st. And this is the data frame that we get. And you have different columns, entity code, date, total cases, and data cases, right? So we're gonna use this for the map. So what we're gonna do is that we're gonna use the geometry in the GeoPandas data frame called world, right? So this is the world data frame in this way. So you can see that we need the geometry information from data frame, but we need the total cases information from the other data frame. So what we do is that the idea here is that we need to merge the two together. So the idea here is to do that we merge the two data frames based on common columns. So you can either merge based on the entity and the country names, but the trick here is that if you look carefully enough, like in this data frame, the United States is basically called United States, but here it's called United States of America. right? So if you merge based on the name and entity, assume you rename it first, and you will miss the US in your map, which looks very bizarre, right? So the best way to merge it, and I think, is to merge using the codes. So these are ISO codes for each countries. So what I do is I'm going to change this to code and then merge the DFC into the world data frame and then use the plot. Okay. So what I do here is first I'm changing the ISO 3 in the world data frame into code, right? So if you do that, after you do this, and you do, after we change it, and then now I can merge the DFC into the world data frame, use the merge function, and based on the column code, right? So what in this code, what GeoPandas does is that taking the DFC column based on the column code and merge the data frame column based on the country code with the proper total cases and data cases, right? So after you do this, and you kind of get, you get the new data frame. So that's the COVID.head. So it's COVID is generated by the merge function. So you can see that I have this is basically the existing world data frame. And now after the merge, I have 4 additional lines, including the entity, the date. These are not going to be useful, but we have total cases and daily cases that can be used to color the map, right? So after the merge, this new data frame called COVID is generated. And now we can use the plot function, which takes the geometry of the COVID data frame and color by the total cases. The code is very straightforward. So this is what you do is that. So now we create a map, COVID.plots, give a figure size, and column now is the total cases. So I'm gonna color the map with this column, total cases. And the color map, I'm using orange to red. And scheme, now I use a user defined, because the default, if you use the default quantile, things like that, it gets you very low resolution of the levels of cases. Right? So how I'm going to define it, I'm using a keyword called classification underscore KWDS keywords. I'm using a dictionary on bins. So I have setting 1, 2, 3, 4, 5 bins in this case. So you can see that, so between 0 to 500, it's colored to very light yellow, and then the highest one between 10,000 and above, and that's dark red, right? So this is a location, this is the code that sets a legend and put a location right down here, right? So this is basically how we did to map the cases of COVID-19 infections into a world map like this. And of course, there are more things to do to make this nicer, but I think the key point is that you need to understand what is the GeoPandas data frame, and how do I get the useful information and to merge them together, and how do I specify the colors and the columns to show the distribution of the data. Right? If you have a clear idea about how to do this, I think you've got it. The point of how to do basic geospatial data visualization. All right, so now let's make some maps.